The normalization or the norm concept, you can define this norm concept with suppose some function. This is n-dimensional function, of course, in a real plane. Real plane here, if I am talking about this whiteboard or this wall, it is, you can say, the two-dimensional real domain in two axes, x-axis and y-axis. Sometimes we can also add up the third axis involvement. Sometimes we also consider the time mentioned. So similarly, so it depends upon the situation. Basically, this norms give us the real length. This norms give us the real length. Condition of the norms should satisfy. Okay, our conditions of norm. First is, for example, any variable in form of norm, it must be equal to 0 or greater than 0. Okay, this is very much important. Or you can say it's 0 on x equal to 0 if only x equal to 0. If you are variable 0, then it will be 0, otherwise it will not. Okay, even x negative value, due to norm, it will show you the positive value. So 0 is the possibility only once there is nothing, no movement. Robot will not observe any disturbance, any information. So it will say that, of course, no length, no distance will be covered. Robotics will not operate. Okay, so this is the situation. Otherwise, if negative, okay, if we are considering negative value, of course, last time.
Is this specific to the robotics or
any applications? Any applications which is depending upon. Okay, here this is the basic linear algebra which is used in deep learning, artificial intelligence. I just use the words robots basically mimic the brain. Okay, robots are usually mimics the brain. All the machines are, though machine language are basically mimicking the brain. So that's why I am talking about this. It's not a big deal. So the second one, you should know about this Cauchy-Schwarz inequality. So it should be like this. If you are considering the expression, it should like this value. Of course, some kind of triangular inequality. Okay, this is a very beautiful concept. Sometime later I will explain. The third one is, third condition, you can say scalar value. Concept of scalar. You can write this concept of scalar. It can be written as a product. Okay, if any scalar, then you want to basically scale up. I will just after this I will explain to you what's the transformation. The scale up the thing. Scalar can be written. Okay, increase the value, or for example, machine want to jump. Small jump, bigger jump. If you want to give the higher power to machine, it will take a bigger jump, or higher. Even in case of audio signal, much energy of the sound waves will be produced. So this is kind of a scale. On our radio or mobile phone, we are scaling up the sound. We are from the speaker. We are getting sufficient amount of sound waves. This is, if we are mute, we are going to mute it. This is the scale. We are multiplying the scale equivalent to 0 almost. So this is kind of a function of a scale. Scale, you can say, if multiply with any variable, change variable. Okay, sound variable, of course, is kind of variable. Some waves are changing. So similar behavior in the machine's language, it can be adopted. Norms. Okay, remember the very, very simple definition of the norms. If I say for memorization. Basically, norm measure the size. It can be 1D signal audio size, it can be the 2D signal, okay, it can be 3D signal. Measure the size of the things, length, okay, width, whatsoever. It depends upon the, technically simple, you can assume that the size of the things. This is, of course, without information of the size, no AI can work, no machine can work. Of course, though it need to produce the level of sound, little sound, high sound. For example, some of the time we are sitting in a conference, we are decrease the sound of mobile phone tones. So if it's not in control, so norms, basically with the help of norms. Even your knob, you are scaling up and down. It's on your screen, touch screen, you can notice there is some kind of a length. Things are really simple. Okay, so norms basically measure the size. Now let we see the different norms, and if we are talking about the basic one, can be, and it is mathematically you need to sum up all the sizes, sum up all the dimensions, sum up all the lengths, index from 1 to m, order may be in m dimensional or m variable. Of course, there should be mx kind of variable, x1, x2, x3. You need to sum up all the dimensions and of course scale. And this is the simplest norm, you can say. And again, condition of the x, it should be greater or equivalent to 0. If, okay, of course, if you are talking about some length, even you are considering the length of a pole or tower, or you can say the power lines inside of a ground, you cannot say it's a negative. Basically, it is having some length. Okay, so beneath the ground, there is some length, concept of a length. So you are simply, you can say your this xi must be greater than 0, or you can say equal to 0. Or if all the xi, okay, all other case, all the length, so these are two possibilities. So this is the simplest form. In this simplest form, you need to basically sum up the total length. Okay, summation, sign of summation already used. In the second, this is also known as Cauchy-Schwarz inequality. In this, of course, if there are two, a moment ago I explained the concept of scalar and variable multiplication. Okay, we see the scale up, scale down. Here, if we will have some two variable like this, then you can write them like a product. However, if you want to, there is a summation sign, okay, sum. A moment ago I told you people, then it will follow the Cauchy-Schwarz inequality. If there is kind of the concept like this, then it must be less than. So, and of course there is certain value, or you can write, if you can want to, this is basically follow the square formulae. But in this square formulae, you can say this one, but sum up, okay, all the values must be less than this whole sum. Okay, there is some concept. If you want, I can display its geometry, but I think this is very basic. I don't need to go in its geometry for you. One another is very much important in deep learning, p-norm. In p-norm, okay, it's usually written like this. P is the value, P is a kind of power, okay, representing some kind of a power. So it can be like summation index 1 to m, and of course P and here. Basically this power will be cancelled out, or you can say that is the p-norm is the simplest. A moment ago I already explained the same thing, that sum of all the length, all dimensions. P-norm is the simplest norm. And in this p-norm, usually they are using the scale kind of formula, so that Euclidean distance, or you can say Pythagoras theorem, simplest, shortest distance from one point to another. Another one is the once you will have P infinite, power is kind of infinite. In this situation, where we need to observe the infinite dimensions, this is the problem, especially in AI and deep learning. In this situation, usually what will do this norm? This norm will consider only the maximum value. Only the maximum value. Because it will consider sum of all the teeny tiny value, then its sum will be definitely infinite. Okay, but in this case, we are considering, for example, the Mars rover is reaching to the Mars or somewhere. So we are considering the maximum. So we are not considering the zigzag pattern or the circular orbit kind of a thing. Okay, so the maximum value is considered, and for this, you will notice in your textbook sometimes that it should be greater than 1. Our index can be reached to maximum value m. M is the maximum value of this. Okay, so it's not some, or you can say magnitude of the biggest element. Magnitude of the biggest element. You should not be confused in the p-norm case. For example, here I am giving you some values of x, 5.3767. Another value is 18.3389. Another value is minus 22.5857. And just for assumption, you can say we are considering here 8.6217. If I am asking, determine the P, you can say infinite norm, then what value you will be chosen?
18.6.
No, why 18.6? 18.10? Negative. I told you, don't be confused. Okay? I told you, if you are considering some power, some pole that is, okay, you are digging the earth, but there is a length of a pole or not inside of the earth, though it is in the negative direction. But of course, it has having some length. This is very much important. Okay. Is it clear? Infinite now? Yes, it's very simple, and hopefully you will use it very nicely. Let's come to the point of transformation. Transformation in 2D. I will portray the simulation of this in form of images. You can say matrix is having some kind of elements. Similar image is having pixels. Pixel value, or you can say intensity value, are the kind of elements. So once we are transforming the image, or transformation in the 2D, it can be done in the 1D. You can increase the signal length. In 2D you can transform it. First one is translation. Second one you can say scaling. Similarly, like rotation, these are the basic kind of applications you can do is by using your mobile phone. Translation, you are, for example, on your mobile screen or on your PC, you want to translate, for example, there is some image, you want to translate this from this corner to that corner, and scaling means you want to increase the size of image. It's initially it's the pixel value 256 into 256, but you want to increase its resolution to 1052 1052. In rotation, you are rotating the image about 45-degree angle, 90-degree angle, one. Okay, these are the best. But there is a mathematics, especially once you are applying the advanced deep learning, robotics or machine language. You need to do this by performing the mathematical operations behind it. You need to know the concept, what is going on. First one, let me explain about the translation. It's very simple. For example, there is a 2D plane, x-axis, y-axis, and see, there is some point, and point value xy. Of course, you are having some kind of a point from the origin, 0, 0. You want to translate it to some new position, and new position can be this one, and at this if p becomes p prime and x becomes x prime, y becomes y prime. Of course, this new position can be labeled with these coordinates. So this one is you translated this p to p prime. So the formula is very much simple. Initially, you are having some vector. I told you vectors, when you have too many vectors, then you can encompass all these vectors in form of matrix. And you are using the MATLAB matrix laboratory to get the required solution. So here we are having, okay, simple vector. So this simple vector, x, y coordinates, we shifted, we translated to p prime position. So what we need to do, we need to multiply this with this matrix. This is the benchmark matrix. Let me explain this to you. With some value, and this value is kind of extension along x-axis, extension along y-axis. Let me explain to you the concept of this matrix. Concept of this matrix is really beautiful. See, first you, at this point, you want to translate along x-axis. This is 1, value of 1. Is there any change in y-axis? I am talking about the only x. Once x is shifted along the horizontal axis, x at this point, this x is shifted to x prime. Okay, this value. Is there any change in y-axis? No. Of course, there is 1 along the x-axis and 0 for the y. So this is the case. So you are multiplying, and once you are shifting this y to upward, is there any change along y-axis? Sorry, x-axis? No. So x-axis 0, and there is y, and you shifted. Okay, you translated with some extension along x-axis tx, and along y-axis is ty. So this is your this vector tx and ty will be summed up, and this one is the original vector, and of course your required matrix will be obtained by multiplying it with this benchmark matrix. This is the translation of the original vector xy by summing up with its extension value tx, ty, and you will get x prime, y prime. Very simple. Machine language is following the vector formation. Okay, and once you want to complicate it more, okay, by 3D, 4D, or even you can deal with the 1D signal, you can play very nicely. The concept of rotation is also playing a wonderful role. You should know about it. it is having some basic values. Let's see, there are two coordinate axes, x-axis, y-axis. So in x-axis, of course, you are considering some vector. And of course, magnitude or length of the vector can be nominated with r. What you will do, you want to rotate it. Initial, there is an angle theta. You can label it as theta 1. But after rotating it to its new position, it will become at this point. And could you please tell me the angle will change or not? Change? And of course, change in angle is labeling here theta 2. And of course, if we are talking about the total angle of the blue vector from this coordinate axis, x-axis, it will be of course sum of theta 1 plus theta 2. And very important thing for your kind notice, is there any change in magnitude of the vector? No, r will be same. So my students, you can easily mention here the change. There is a here this one is the simple vector p, x, y, and of course new vector become p prime, x prime, y prime. So what you will do, you need to know the rotation of the vector, or you need to know the p prime. For this, you can say x prime, and x prime can be obtained how? By following the trigonometric ratio. Trigonometric ratio, you can start from this simple trigonometric ratio, for example right angle triangle, for this one, and of course at this point this is simple x and this is r. So you can use the trigonometric ratio of cos theta. Cos theta is what? Basically this is x-axis, this is x-axis. So base over hypotenuse. So you can say cos theta 1, because we are talking about the first vector, equivalent to what? X over r, or you can say x equivalent to r cos theta 1. Is it very difficult? No? No. Okay, now we want to know the value of x prime. In this case, you can say cos theta 1 plus theta 2. Of course, what? X prime over r, because magnitude of vector will not be changed. So your x prime will become r cos theta 1 plus theta 2. Is it okay? So here you will apply the basic trigonometric ratio, that is the simplest concept in OA level or SSC matriculate classes, that if you are having cos alpha plus beta, it's equivalent to cos alpha cos beta minus sin alpha sin beta. Can you please recall your memory? Yes. Yeah, that's okay, thank you. So by replacing the value of alpha and beta, theta 1 plus theta 2, you will get r cos theta 1 cos theta 2 plus minus sin theta 1 sin theta 2. Okay, so this one is like this. However, from this you can substitute the value of this r cos theta 1. Similarly, at this point, so this one, of course, it will multiply with whole. So r sin theta 1 will be replaced with x and y coordinates. Is it okay? Is it clear or not? Please ask me if it is not clear. Clear? Similarly, here we get the x r cos theta 1 by considering the y. Okay, so we will get of course sin theta. Trigonometric ratio of perpendicular is sin theta equivalent to perpendicular over hypotenuse. So perpendicular is y. So we will replace this x cos theta 2 minus y sin theta 2, and this is what basically x prime. Once you will consider, we are talked about this x prime. Similarly, you can get the y prime. Y prime by considering the similar kind of trigonometric ratio, and you will deduce y prime, and of course y prime will come from sin theta 1 plus sin theta 2, and on further simplification you will get y prime. Here the formulae for this sin theta cos theta is kind of a little bit different. Is sin theta 1 cos theta 2 plus sin theta 2 cos theta 1 r. So by substituting its value, we will get y cos theta 2 plus x sin theta 2. So by arranging it in proper order, we will get x, okay, x value at first place and y value at second place, x sin theta 2 plus y cos theta 2. So this will give us y prime. And this is your second equation. Now these are the equations, linear equations. Once we will get each linear equation is representing some kind of vector formation, we need to consider both the linear equation 1 and 2. This one is the, you can say 1, okay, x prime and 2, then we will have x prime x cos theta 2 minus y sin theta 2, y prime x okay, sin theta 2 plus y cos theta 2. My children, you can notice you need to determine x prime, y prime. Here you are going to make a metric formation of this. It can be written like scaling things are what? Scaling. In scaling, you are increasing the size of object, decreasing the size of object. Okay, you can change the machine's manual by increasing or decreasing its approach, okay, according to the size. In this case, what will happen? Basically, you need to know again x prime, y prime, and of course what you will multiply original x with some change, and this change should be small. I will prefer that if you will consider a big jump, then convergence will not be attained. For example, you are at the peak of mountain, you want to jump to reach on a ground, then of course you can hurt yourself. Small steps, okay, will help you out to reach on the ground safely. So this is the delta x, okay, along x-axis, small change. Whenever you will see the delta, it is representing the small change. Similarly, if you are making some change along the y-axis, of course, in scaling you can preserve, you can keep one axis at its position and you can change another. For example, in case of image, we have some passport size image and digital format. We want to extend just its horizontal axis. You can say the face will look like a fatty face. You want to on your computer screen, you want to if you want to keep your x-axis, but you want to increase or decrease vertical axis, then it gives you some kind of a slim face, or you look like skinny. Okay, this is the manipulation. So here you can keep it as a constant, or you can change almost no y-axis, y-axis 0. So if you want to change in a uniform pattern, okay, both x-axis as well as y-axis. For example, there is an image of 256 into by 256 the pixel values. You want to increase it to 10, okay, 52 along x-axis, 1052 along y-axis. So you need to consider give you an provide you an input with the same values. Okay. How it works? It works very simple. Again, like the first one, kind of a translation one. So I did translation with scale of 1. You can translate with scale of 2, with scale of 100, whatsoever you will provide. Okay. So this is the xy, and here delta x 0, 0 delta y, and of course you need to multiply this with original x, original y. Is it really difficult? No, very simple. You can scale up, scale down, or you can maintain the uniform scaling up or uniform scaling down. Okay, there are varieties of things. One another peculiar information can be raised in your mind. So we are talking about vector, and vector is following the two main themes, two main point of information. One is its magnitude, another is its directions. Yes, please.
सर वो जो हमने रोटेशन वाला पढ़ा सर, उसमें क्लॉकवाइज और एंटी क्लॉकवाइज होती है, तो उसके लिए इक्वेशन डिफरेंट होगी या सेम रहेगी?
Yeah, just you need to change the sign. For example, here in case of y-axis there is negative sign, of course it will go in the opposite case, and then it will rotate anti-clockwise. Okay, just you need to change the sign, because trigonometric angle on which side you want to translate. This one is the anti-clockwise. Usually we are doing. Okay, this one is the anti-clockwise. So because on x-axis here you are going like this. Okay, from 0 to 90, 180, then to 360. Okay, this is other way you can do, of course, just negative sign. Reverse, okay, reverse direction. Very good question. So you can think that vector is having some kind of a direction, but sir is telling us that vector is containing some kind of an information data. For example, if we are talking about some house, and house is having some kind of a area in terms of square meters. Yeah, you can say number of bedrooms, 2 bedrooms, washroom, okay, or bathroom, 1 bathroom, 1 kitchen, and price is 50 lakh. So these are the things, and of course you can write this in form of a vector 120 to 150. This is for the one house. Okay, these are the attributes value, or you can say features value. But you can say, sir, it's kind of a vector R, or you can say vector of the house. Okay, H. So is its direction, what is its direction? Basically it is talking about house. It is talking about house. Direction is kind of your intention. And it can be, if you are focusing the price of the house, of course it can be vector can be go this side. If you are giving some priority to the scale area, it can be given upward. But technically, your intention is kind of your direction. That you are going to buy some house. You are talking about some house. This is direction of the vector. Magnitude, you know, magnitude is having some kind of a value inside of it. That it's the number of rooms, bedrooms, bathroom, kitchen, its value. All these are basically, these are the elements. Like in image, you are having some kind of image, its brightness values, pixel values, it's kind of the elements, attributes, features. Okay. Similarly, you should, for example, if we are considering one more house. Okay, now two house. Scalar is very simple. You just need to multiply with 2. From 1 it becomes 2. Scalar. But in case of vector, of course, vector is the same thing, but direction is toward the house. You are talking about house. Is it okay? You should not be confused about this.
सर इसको हम सिस्टम के पर्सपेक्टिव से देख रहे हैं या मैथमेटिकल लाइक मतलब हमने एक सिस्टम बनाना है
Yes.
तो हमने अगर वो मतलब कि वो फिल्टर करने हैं ना उसके क्यूरीज कि मतलब 2 बेडरूम का अच्छा है या ये तो एक घर के वो फीचर्स हो गए
Exactly, features.
तो हम उसी तरह उसको फिल्टर करेंगे फिर
Brilliant. Exactly same way. Because we are visiting, we are observing too many houses. We need to optimize the value. Sometimes we are not focusing, we have enough money, okay? You can say looting money nowadays. But we have enough money. We are focusing the area of the house. Okay? It depends upon the, you can say, systems. What kind of system you want to develop? What is your priority? What is your demand?
तो सर ये हमें प्रिडिक्शन में वो करेंगे कि मतलब लाइक मैं सर्च कर रहा हूँ ना कि मैं वो 2 बेडरूम का देख रहा हूँ या 50 लाख के प्राइस में वो देख रहा हूँ तो जैसे नेक्स्ट में कोई ऐप खोलता हूँ लाइक ज़मीन.com या वो OLX तो वो मुझे आगे जो सजेशन आएंगे वो उस पिछले डेटा बेस पे
Exactly. Without data, they can't work. They will, if you are going to, for example, your new website, kind of a Zameen.com, Granan.com, and any other site, if you are not feeding you are not having any sufficient data, it will not give you the right prediction, okay, exact prediction.
एक तो सर हम क्यूरी भी लगा लेते हैं ना सिंपल के कैटेगराइज कर दे उसमें क्यूरी लगी हो कि सिलेक्ट ऑल फ्रॉम वेयर 120 वो तो सिंपल क्यूरी होगी एक प्रिडिक्ट करेगा सर पिछले डेटा पे तो ये वहाँ पे हमें काम आएगा.
See, your AI deep learning accuracy is depending upon the amount of data.
Yes.
If data is high, prediction accuracy is high. If data is less, of course, it will not much accurate. Good. Last time I explained to you people about the concept of CT scan, or you can say computerized CT scan or computerized tomography. In this situation, you can say some vector R kind of a, okay, some body, or this is some kind of a body, here is the origin place, at some point gamma rays are kind of this. Remember the thickness of gamma rays dx. Okay, though it's long x whatsoever, just we are considering the dx, small, not big, okay, small rays. So, to construct function from this measurement, basically we want to know the object frame or object scanning system. Of course, system will work in form of your computerized tomography camera will work in form of rotation around the body. And what you will do, you will, a moment ago, we constructed some matrix, and this matrix A, and you should say this matrix, okay, rotation matrix. And sub is just for learning. That A is the rotation matrix, and what should be the value of this? And of course, its value is kind of cos theta, sin theta, I don't remember exactly. Yeah, this one, okay. If you are talking about anti-clockwise. Minus sin theta, so sin theta and cos theta. This is your rotation matrix. Your camera will, of course, taking frames by, okay, you need to, your this function, basically your function, okay, function, of course, if your function output, you want this, x, y, it will give you it's the combination of this, where R and Z. R here represent some kind of gamma rays, okay, along, you can say these are the axis, these are the axis new values. Here, like this one is the x prime, y prime, we can write it like this also, it's not a big difficult deal. This one is the x, okay, in order to, alright, so this is it okay? Last time I explained a little bit, so just this time we studied in a fresh way. So rotation of your camera will work with this way. So it will store and then at the last what you will do, you need to sum up from 0 to 360 degree, sum up. I told you the concept of summation. All the gamma rays, okay? So in rotation case, of course, and if you are talking about this, dx, dy, so double integral. Are you getting my point? Very simple. This will give you your desired result. Sometimes in textbook, instead of a double integral, they just use only single integral, mean that sum up all the values they are using to increments dx, dy, what you can take it. But if you are using the infinite number of gamma rays, of course, from minus infinity to infinity, it will go like this. You are slicing up for getting the better and high precision as, see, in this case, data you are retrieving, you are collecting from the body, but you need to slice up, okay, the gamma rays into slightest possible slices, so that body should be scanned very closely. There should not be a big gap for better accuracy. But sometimes, if you are talking about Zwin.com, if you want to predict the future by considering the past, you need a big data of the past. And the concept in this CT scan here, in this computerized tomography is used, you can study it by yourself, radon transform. In radon transform, this okay, you can do any kind of project on it. You can check out the study material, research articles, and or you can get the research article about computerized tomography and artificial intelligence, deep learning, and you can discuss with me, we can work on it. But it depends upon your interest. This is just kind of a clue that you can proceed in this direction too, if you have some interest. Similarly, MRI is a little bit another thing here, but you can proceed in that direction too. However, it's not too difficult, but this is it totally depends upon your interest. Okay, we can discuss it, how artificial intelligence, how deep learning works, like we can get a better outcome. And first, it is just for storing purpose. Similarly, for reconstruction phase, you need to apply the inverse radon transform. Radon transform is for collection of the data, okay, for first phase. Once you want to get a scan of the image in form of an X-ray sheet, or just you need to apply the inverse radon transform. Any question until here? No? No question, please? Okay, you can rest. After 10 or 15 we will start again. Is it okay?
Yes, sir.
If there is any question you may ask, please. No?
सर आपने बुक बता दी
I will provide you the soft copy of book. Okay?
Yes.
Yeah, yes, please. I'm sorry.